So what are the things we learned from the first unit in the initially? I mean, we discussed about the course objectives and then course outcome which are related to the mobile communication and computing. And then we discussed about the different terminologies which are related to the mobile computing technologies. We discussed about what is meant by mobile equipment, mobile hardware, mobile software, how that works, and then we discussed about the security terms, right? How the communication is more secured when the data or information is transmitted from one device to other devices. In the later part, we discussed about different history from where it has started and where it is reached now, right? The evolutions. Also, we discussed about different telecommunications standards. We discussed about ITU, International Telecommunication Union. Also, we discussed about uh, ETSA, Electronic Telecommunication, or European Telecommunication Standard Institute, right? Also, we discussed about the different generations through which from zero generation to the fifth generation, how it has evolved, and what were the technologies used in each and every generation, start from the zero generation, first generation. The first generation, they have used AMPS, Advanced Mobile Phone System. And then the second generation, they have used, I mean, second generation, which is called GSM, Global System for Mobile Communication, and that they've used digital signals or digital communications, right? And then third, we say that, which is the 3GR, we used to say that UMTS, Universal Mobile Telephone System, or HSP. There are different versions, right? High speed packet access, right? Also, I mean, under the 2G itself, we add the other categories, GPRS as well as Edge. And then third generation, we discussed about the 3GR UMTS, and that uses wide WCDMA, wideband code division multiple access. Then we discussed about the fourth generations, how the fourth generation which works, which is based on LTE, long-term evolutions, right? And in each and every generation, we discussed about what are the services which offered, and then what was the data rate which is accomplished in the specific generations, right? So these were the few contents which are related to the history as well as the telecommunication generations, right? We discussed. Then we discussed about the cellular system, and that under the topic we discussed about various basic elements which are related to the mobile communications. We discussed about the cell. When we talk about the cell, it's a the geographical location, right? How a base station which covers or which provides a coverage. When you talk about a base station, it's a unit, or I could say that it's a tower which consists of multiple telecommunication devices like antennas, transmitter, capacitor, and then it connected with the different fiber optic cables, which will provide one base station to other base station, which will be connected through the fiber optic cables, right? So that is called a base station. We discussed about a mobile station or mobile terminal. When we talk about a mobile station or mobile terminal, that is your the handset or the mobile phone, whatever we uses. Also, we discussed about what we discussed again. We discussed about the cell size, right? We discussed about various the chances, the different isotropical isotropic devices, which can become a shape of a cell, right? After that, we discussed about how the hexagon, which is the best shape for telecommunication cells. Also, we discussed about the cluster. When we talk about the cluster, it's a group of cells. Why they are going for this cellular system means, in the first generation, they use a single high power antenna that required that had required a lot of energies in order to transmit the signal to the longer distance. The GSM idea was to replace the single high power antenna with multiple low power antennas, right? And all the low power antennas, which will operate with the different frequencies. After some distance, the same frequency will be used by other base stations or other cell. The concept of using the same frequency after non-overlapping distance, so that is called the frequency reuse. Also, we discussed about the and off or and over procedures. What is meant by this and off or and over procedures? Whenever the user is in a call in a service, and if the person is talking on the phone and at the same time he is moving from one base station to other base station coverage area, In that cases, whenever you move from one cell to other cell, all the control units from one base station that will be completely hand over to the other base station where the user is entering. So without connecting the call. So this was called a handover or handoff. Then later part, we discussed about, again we discussed about different channel allocations. We discussed about sectorization. Yesterday also I was giving a glance about what is mean by sectorization, right? Also we discussed about the fixed channel as well as the dynamic channel allocations, how the channel will be allocated to the users depends upon if the number of users increases in this specific cell. Also, we discussed about some other topics which are no, related to the electromagnetic waves. Especially, we discussed about seven range of frequencies or seven range of signals. We discussed about the radio waves, and then we discussed about infrared waves, and then we discussed about the microwaves. We discussed about visible lights, and then X-rays, and then ultraviolet rays, and then we discussed about the gamma rays. We detailedly discuss about each and every rays or waves frequencies and the specific application where it is actually used in our day-to-day applications. That we completely discussed about with the frequency range, right? Then we discussed about the antennas, right? Again, we discussed about depends upon the propagation, isotropic antenna, and then directional antennas, and then based on the aperture, we discussed about dipole antenna, and then we discussed about helix antenna, loop antenna, right? So these are the some of the things which are related to the antenna, right? Again, when we talk about antenna, antenna is an electronic device, which will carry the electromagnetic signals from the air medium, and that will be propagated, that will be transmitted to the connected devices through the coaxial cable which is connected with that. From the antenna to the TV, the data, the signal that will be transmitted through a conductor, whatever the wire or connector medium which is connected are attached with it. Then also we discussed about what we discussed in last lecture. Yes, multiplexing techniques. We discussed about the various multiple access technique. We discussed about the frequency division multiple access, time division multiple access. Also, we discussed about space division multiple access with sample analogies, right? How the road which was divided into different lanes, right? And we discussed about with the different examples, right? Also, we discussed about the code division multiple access. So I think this is a quick recap for the topic which I have covered. Do you have any doubt with the module which I have covered or the topic which I have covered so far in the mobile communication subject? If you have any doubts, you can feel free to write in a chat box or unmute yourself and then ask your query. I'm happy to clarify your queries. I'll wait for 10 seconds. All the, I think yesterday I posted a PDF file in your official group. So that PDF file which consists of all the video lectures which are uploaded in the YouTube or Drive, and that is for your easy access. Apart from that, whatever the presentation slides which I am using for my lecture, all the contents which are uploaded in a single drive, I shared the complete drive with you. You can access those materials. All the videos as well as the PPTs which are links are given in the Moodle account also. You can log in into your Moodle account and then you can appear for the weekly quiz, and then you can refer those videos which are conducting day by day, and that is same the link which is uploaded or updated in the Moodle, and you can use the same. I hope it's clear for all of you about the unit 1. Shall we proceed? Shall we proceed with the module 2? Okay. I'm getting quite responses from all of you. So this is our the second module. In that, we are going to discuss about a mobile communication system. Especially, we are going to discuss about the three elements or three subsystem which are related to the second generations. The first one is that we'll detailedly discuss about global system for mobile communication, or we call a GSM. And the second module which we are going to discuss is that GPRS, which is called a General Packet Radio Service. And the third one is that we are going to talk about UMTS, which is Universal Mobile Telecommunication System. So these are the three modules we are going to detailedly study under this module. Now, the first module, the first topic which I'm going to cover in this module is that global system for mobile communications. Now, how many of you know how your mobile phone works? How many of you know how your mobile phone works? Anyone can unmute and then respond, or you can give your comments. How your mobile phone works? You have the mobile phone which is integrated with the different electronic equipment or electronic devices, each and every device which is intended to carry out the specific task. How the communication, how the signal which transfers from your mobile to the any devices which is connected to your, maybe even if you are sitting next to each other, if you are sending a message or if you are making a call, how that directly it reaches to the receiver. Can you understand my question? Suppose if there are two users, your friends are sitting together, even in the same campus. Let's take in the same campus, our campus example, right? Both of you are staying in the same classroom, right, on the same floor. If you are making a call, how the call is originated, how the call is connected, any idea? Ayan Sheikh, are you there? Ayan Sheikh, unmute yourself. Can you explain how the mobile phone works whenever you are making a call? Ayan Sheikh, Ayan Sheikh, are you there? Abdul Aziz. Okay, I'll quickly explain how the mobile phone works. Say, for example, suppose if I have this mobile phone right now, whenever I'm speaking, what it will perform. So, whenever I'm making a call, right, once if the call has been connected, let's assume the call is connected. After that, whatever the information which I'm speaking, the wave signal, the audio waves, no, that is in the analog signal. So that will be received from the microphone which is attached with the phone, and that will be converted into the digitals, right? The analog signal that will be converted into digital signals using the different modem, as well as we used to say that modem modulators, right? With there are multiple sensors are there, MEMS sensor there. So that will convert our the audio signal into digital signals. Now those digital signal that will be transmitted through when we were discussing about the antennas, sorry, the generations of telecommunication, the first generation mobile which add the antenna which is outside the device, right? And in the advanced telephones or advanced mobile phone, they have add a inbuilt mobile which is placed inside the mobile itself. The antenna, what it will perform, it will transfer the electro signal, digital signal in the form of electromagnetic waves, as we discussed about different electromagnetic waves rays. And the antenna will transfer the electromagnetic waves to the base station, or maybe from one person to other persons, right? But naturally, these electromagnetic waves, there has some certain restriction. This cannot be propagated to the longer distance. So again, so we also discussed about different signal propagations. In the first unit, we discussed about line of sight as well as ground wave propagation, as well as point-to-point propagations. And we discussed about some of the path classes. Whenever if any electromagnetic waves or any signal which no touches or which play, touches on the obstacles or maybe the wall or maybe any dense obstacles, there are chances that the signal may scatter or may take diversions, or this is called a multi-path propagations, right? The signal may delayed in reaching to the destination. There are chances that this electromagnetic wave during its transmission, there may be a losses. Instead of that, what they could do is that whatever the nearest base station which is connected, I mean the tower, so that will receive the signals. The electromagnetic waves will be received by the antenna which is connected, receiver will connect, and from the base station I could say that it is a tower. The base station which is connected with the connection oriented cables, that is called, we used to say that optical fiber cable. So that electromagnetic signal which will be converted into optical signals, that optical signal will be transmitted to the receiver tower. Suppose if I am making a call from Mumbai to Tamil Nadu, what will happen? All these from my location, I'm staying in Mira Road. From my mobile, all the digital information in the form of electromagnetic waves, so that will be transferred to the nearby base station. From that base station, the data will transfer through the fiber optic cable, and it will reach to the, say for example, if I'm making a call to Chennai, and all these the data will be transmitted through the fiber optic cable and reach the destination base station. And from the base station, from the Chennai base station or tower, and from that point again, what will happen? The electromagnetic waves, I mean, that reverse process will be carried out whenever it reaches the base station, which is attached with the fiber optic cable. The optical signal that will be converted into electromagnetic waves. That electromagnetic waves will reach to the receiver phone. Again, that whatever the small antenna which is attached with the receiver phone, that will receive the electromagnetic waves. That electromagnetic waves will be converted into digital again. That digital signal will be converted into analog signal, and that only the receiver will hear as a audio message or audio. Is it clear for all of you? If you are clear with that, I've attached with the small animation video. I'll play it, and meanwhile I pass whenever it is required, and then I'll explain parallelly. So this will make you to understand it clear, because it's an animated video. So you can able to see everything, all the
For
operations.
most of us, a mobile phone is a part of our lives. But I'm
Can you hear the sound? Can anyone respond in the chat box? Yes. Suppose if you are not able to hear the noise or voice or audio, you can write in the chat box quickly.
sure your curious minds have always been struck by such questions as how a mobile phone makes a call and why there are different generations of mobile communications. Let's explore the technology behind mobile communications. When you speak on your phone, your voice is picked up by your phone's microphone. The microphone turns your voice into a digital signal with the help of a MEMS sensor and IC. The digital signal contains your voice in the form of zeros and ones. An antenna inside the phone receives these zeros and ones and transmits them in the form of electromagnetic waves. Electromagnetic waves transmit the zeros and ones by altering the wave characteristics, such as the amplitude, frequency, phase, or combinations of these. For example, in the case of frequency, 0 and 1 are transmitted by using low and high frequencies, respectively. So if you could find a way to transmit these electromagnetic waves to your friend's phone, you would be able to establish a call. However, electromagnetic waves are incapable of
I'm facing some issues. Is the screen visible?
Objects, electrical equipment, and some environmental factors. This phone, you would be able to establish a call. However, electromagnetic waves are incapable of traveling long distances.
Why these electromagnetic waves are incapable of transmitting to the longer distance? I was explaining about this electromagnetic waves. Whenever if you are transmitting these waves, so all these are the audio waves, I mean the sine waves, right? The sine waves, whenever it traveling in the air medium, very similar to that voice or the audio. Suppose if your TV is running in your home, and if you are watching some movies, the audio will be very clear when you are close to the TV. And if the distance increases, even if there is no obstacle in between, automatically the voice or the audio will be reduced when you are moving further from the TV. Very similar to that, this the electromagnetic waves, this whenever it's traveling in the air medium or a free space medium, right, automatically due to some other substances or due to some other reasons, maybe the rain or weather, might be due to the climatic changes, this naturally it tends to lose its intensity. Is it clear for all of you?
They lose their strength due to the presence of physical objects, electrical equipment, and some environmental factors. In fact, if there were no such issues, even then electromagnetic waves would not carry on forever due to the Earth's curved structure. To overcome these issues, cell towers were introduced using the concept of cellular technology. In cellular technology, a geographic area is divided into hexagonal cells, with each cell having its own tower and frequency slot.
What is the name of the cell? See, I was explaining about different types of cells, right? The cell which is center excited cell or edge excited cell. What is the center excited and then edge excited cell? Suppose when you talk about a cell, if suppose if the base station, the tower which is placed in the center of the cell, so that is called a center excited cell. Suppose in some application, right, where the antenna has to be placed at the periphery of the cell, so in order to provide a coverage to only the specific direction, so that is called edge excited cell. So whatever the diagram which is shown here, which is you are seeing on the screen, so these are the example for the center excited cell, where the base station which is placed in the middle of each cell. Is it clear for all of you? Oh God.
For most of us, a mobile phone under the ground or the ocean to provide national or introduced using the concept of cellular technology. In cellular technology, a geographic area is divided into hexagonal cells, with each cell having its own tower and frequency slot. Generally, these cell towers are connected through wires or, more specifically, optical fiber. When you speak on your phone, your voice is picked up by your phone introduced using the concept. In cellular technology, a geographic area is divided into hexagonal cells, with each cell having its own tower and frequency slot. Generally, these cell towers are connected through wires or, more specifically,
Video
optical
first, I'll
fiber
explain later.
cables. These optical fiber cables are laid under the ground or the ocean to provide national or international connectivity. The electromagnetic waves produced by your phone are picked up by the tower in your cell and convert them into high-frequency light pulses. These light pulses are carried to the base transceiver box located at the base of the tower for further signal processing. After processing, your voice signal is routed towards the destination tower. Upon receiving the pulses, the destination tower radiates it outwards in the form of electromagnetic waves, and your friend's phone then receives the signal. This signal undergoes a reverse process, and your friend hears your voice. So, it's true that mobile communications are not entirely wireless. They do use a wired medium too. This is how mobile communications are carried out. However, there is a big issue that we intentionally left unanswered. Mobile communication is only successful when your tower transfers the signal to your friend's tower. But how does your tower know in which cell tower area your friend is located? Well, for this process, the cell tower gets help from something called a mobile switching center. The MSC is the central point of a group of cell towers. Before moving further, let's explain more information about the MSC. When you purchase a SIM card, all the subscription information is registered in a specified MSC. This MSC will be your home MSC. The home MSC stores information such as service plans, your current location, and your activity status. If you move outside the range of your home MSC, the new MSC, which serves you instead, is known as a foreign MSC. As you enter a foreign MSC region, it communicates with your home MSC. In short, your home MSC always knows which MSC area you are in. To understand in which cell location a subscriber is within the MSC area, the MSC uses a few techniques. One way is to update the subscriber location after a certain period. When the phone crosses a predefined number of towers, the location update is again done. The last one of these is when the phone is turned on. Let's try to understand all of these procedures with an example. Suppose Emma wants to call John. When Emma dials John's number, the call request arrives at Emma's home MSC. Upon receiving John's number, the request will be forwarded to John's home MSC. Now, John's MSC checks for his current MSC. If John is in his home MSC, the call request will be immediately sent to his current cell location, and it checks whether John is engaged on another call or if his mobile is switched off. If everything is positive, John's phone rings and the call will be connected. However, if John is not in his home MSC, John's home MSC simply forwards the call request to the foreign MSC. The foreign MSC will follow the previously explained procedure to locate John's phone, and will then establish the call. Now let's discuss why the frequency spectrum is quite important in mobile phone communications. To transfer zeros and ones in digital communication, each subscriber is allocated a frequency range. However, the frequency spectrum available for cellular communications is quite limited, and there are billions of subscribers. This issue is solved with the help of two technologies. 1. Frequency slot distribution, and 2. Multiple access technique. In the first technique, different frequency slots are carefully allocated to different cell towers. In the multiple access technique, this frequency slot is efficiently distributed amongst all the active users in the cell area. Now the big question: why are there different generations of mobile phone technologies? 1G originally allowed users for the first time to
See, what actually this video I played to intent is that to understand how the mobile communication works, as I explained, right? So here I think you would have got a clear idea how the mobile phone works. Basically, whenever you are making a call, automatically, as I mentioned, your voice will be converted into digital, and then digital signal that will be converted into electromagnetic waves. The electromagnetic signal, so that will be transferred to the nearby base station. From the base station again, that will receiving the electromagnetic waves. So that will be converted into what? Optical signal. That optical signal that will be transferred to the receiver base station, and then the reverse process will be carried out. And they were explaining about the mobile switching center, and then the other information that we will discuss in the due course also, that are the part of the GSM architectures. So which we are calling as the home location register as well as the visitor location register. Suppose how that could be I explain is that, suppose if I am a person from Chennai, if I bought my SIM card from Chennai, so that the region where my mobile is registered, that is called my home location register. Whatever the switching center which is associated with my home location register, that is called my home MSC, which is mobile switching center. Automatically, suppose if I am there in Chennai, suppose if any person calling to my mobile, if I am there in my native place, in my home register, first of all the calls that will be directed to the home location register are where my mobile is registered. And then suppose if I am there in that place, again my call will be connected. Suppose even if my SIM card is registered with the Chennai, currently if I'm locating, if I'm working in Mumbai, what will happen? And then from the home location register, it will get the information where my SIMs are active. So based on that information, that is called a location registers, right? This location registry information that will be keep on updated to the network operator based on the certain information. So whatever the SIM card we have, right? What is the full form of SIM? Anyone can write in the chat box. We are using a SIM card, right? Every one of us, we are using a SIM, irrespective of any the telecommunication operators service, right? We are using a SIM card. What is the SIM card? It's the unique number which is assigned to the mobile, I mean, the subscriber, which is called subscriber identity module. That is our SIM card module, right? How the SIM will be identified? Again, using IMSI, International Mobile Subscriber Identity. So that is again, so at backside of your SIM, you will see that near about 15 to 16 digit number. So that is going to represent a unique ID or unique identity value for your SIM card, that is identified using IMSA value, right? International Mobile Subscriber Identity, right? So based on that information, it will know your location will be periodically updated to the telecommunication operators, right? Whenever if the person is making call to you, automatically that they will have the record currently where you are residing, right? Based on that location information, next time they will try to forward to that direct the base station where I am residing. So this is what actually happens when we are using that GSM, 2G or 3G, all type of network, all type of system, right, which uses or follows this the location registry based, right? So this is what the logic they are trying to explain. Apart from that, they were explaining about the frequency division, multiple access, sorry, frequency division as well as multiple access technique that also we discussed in the last lectures. Do you have any doubt with the basics of the telecommunication system, how it works? Once if you are clear with that concepts, then it will be very easy for you to understand the further concepts. Do you have any doubt so far what we learned in this module or in this session? Okay, okay. Bharat gave responses, two answers. And don't forget to write the attendance in the chat box quickly. Any doubts so far? Whatever the basic concept which we were